Most students think every truss problem must begin with support reactions, so they immediately start taking moments, solving equilibrium equations and calculating reactions. But not always. Sometimes you can start solving the truss immediately. At every joint, we only have two equations, sigma fx equals 0 and sigma fy equals 0. That means, at a single joint, we can solve at most two unknown forces. So before writing equations, the first thing we should do is count unknowns. So here is the real strategy. Before calculating reactions, look for a joint that already contains only two unknown member forces. If such a joint exists, we can start there immediately. No reactions required yet. Look at this truss. At first glance, it may seem that reactions must be calculated first. But now look carefully at joint C. Only two member forces are unknown there, BC and DC, so the joint is directly solvable. So let's isolate joint C. First, sigma Fy equals 0. The vertical component of FDC must balance the load P. So FDC times sine alpha equals P. Therefore, FDC equals P divided by sine alpha. Next, sigma Fx equals 0. The horizontal member FBC balances the horizontal component of FDC. So, FBC equals FDC times cosine alpha, or FBC equals P cotangent alpha. And now let's substitute numbers. If P equals 10 kilonewtons and alpha equals 37 degrees, then FDC equals 10 divided by sine 37 degrees, which gives approximately 16.6 kilonewtons, and FBC equals 10 cotangent 37 degrees, which gives approximately 13.3 kilonewtons. So the truss analysis has already begun and can be finished, without calculating a single support reaction. But this strategy does not always work. Look at this truss. At every joint, there are too many unknown member forces. No joint can be solved immediately. So in this case, we must first calculate the support reactions before starting the method of joints, or any other method. The real skill in structural analysis is not writing equations. It is recognizing structure, seeing where the solution wants to begin, and noticing when the structure can already be simplified before solving. And this is exactly how we think about structures throughout the course, physics and structures made simple for architects. Not isolated procedures, but clear principles and smarter decisions. If you'd like to continue building this intuition, the next lessons are on screen now.